Today's lesson is 5-3 is long. All right, 5-3 is split into 2 days. All right, and it's good that it's split into 2 days because it's not two totally different topics. They're semi-related, but you could definitely make the argument that it's two totally different topics, ideas. PowerPoint is up for those of you that want it. You'll probably want it for this next slide. Okay, if you're studious at taking notes because there's a lot on the first slide. Okay, easily.
Have you thought of getting the quiz?
Already in.
When do you come in?
Today. If we get time, we'll go over them. But we're going to be pushing, all right?
What was our average?
Decent. It was like an 80.
Really?
Yeah, it was decent. All right. So, like I said, the first slide, there's a lot there. This first definition is polynomial in one variable. Okay. If you remember from 5.1, they talked about it then. We said we're going to come back to it. Here's us coming back to it. The definition kind of throws everybody off. All right. Mostly because of this right here. All of this ugly, generalized mathematical notation that people think makes sense to everybody, and clearly it does not. A polynomial in one variable is an expression of the form, let me get technical, a sub n times x to the nth plus a sub n minus 1 times x to the n minus 1 plus yada 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 plus a sub 2 x squared plus a sub 1 x plus a sub 0. Blech. No. Here's what it means. Here's what it means. Ready? All of these a sub n's here, the a's in front, they're all coefficients. They're all just numbers. All the x's, they're x's to some exponent. In order. Okay? That's all it means.
So do I really need to write
You really don't. Because it's just going to confuse you.
Okay.
All right?
I
I know. All the a's are just coefficients. All the x's are just x variables to exponents in descending order. So let's say n is 5. This would be x to the 5th. The next one would be x to the 4th. X cubed, x squared, x none. Just like your homework from last night. Okay? All of those that you divided were examples of polynomials in one variable. Okay? So if you're confused about that, that's all you need to think about. Think about your 5.2 homework. All right? A sub n is not equal to 0. A's are all real numbers, no imaginaries. N is a non-negative integer because they're positive exponents. Okay? So all of that's holding true. Everybody good? So if you don't write this definition down, at least make sure you understand what a polynomial in one variable is. We're going to go do a couple examples after this of it. Make sure you get the rest of this paragraph down though. Okay? The polynomial is written in standard form when the values of the exponents are in descending order. That's super important. So make sure, just like your homework from last night, okay, it's one of the main reasons why I wanted you to keep it. That way you can go back this weekend and look at it. Okay, make sure it goes down in descending order from the 5th to the 4th to the 3rd to the 2nd to the 1st, just like all the problems you did. Okay, Ron?
Well, you ever show us when x is not a 1 or 0, whatever it was? You didn't show us that.
When the leading, no, we're not going to do that. I know what you're talking about. We're not going to do it. Okay. The other two definitions up there are very, very important. Not so much for today, a little bit, like we're going to do it just a little bit, but definitely important the next time I see you. The degree of a polynomial is the value of the greatest exponent. Okay, and then the leading coefficient is the coefficient of the first term of a polynomial in standard form. So those two definitions are two talking points of any polynomial. So to kind of summarize everything, you write a polynomial in standard form when you're going from the biggest exponent down. Okay? If you look down here, there's some examples. X squared, x cubed, how they go down. Okay? You don't have to. The word degree is talking about the biggest exponent. All right, whatever the biggest exponent is in your polynomial is referred to as the degree. So if you look at this white box, you can see here, this 4x minus 9 is the degree of 1. 5x squared minus 6x minus 9, the biggest exponent is 2, so it's degree 2. 8x cubed, yada yada, degree 3. Make sense? Okay, degree just means biggest exponent. Look.
So variables are always the highest degree? Like, and that's n. That's n. Is that,
Yes, yes, yes.
what if you have two variables?
You won't. That's why it's polynomial in one variable. Okay? X, Y's are out. Just X's. Okay? The leading coefficient is basically the coefficient that's attached to your degree. Because if it says the first term in standard form, but if it's in standard form, the biggest exponent goes first. Which is why it's key to make sure you write the polynomials into standard form. So for example, with the same ones. 5x squared minus 6x minus 9. X squared was the biggest exponent, so the degree is 2. The coefficient attached to it is 5, so your leading coefficient is 5. For the cubic, your biggest exponent was 3, so degree 3. The coefficient attached to it is 8, so your leading coefficient is 8. Very important to make sure you write these in standard form. Okay, that way it's pretty easy to tell. So, state the degree and leading coefficient of each polynomial in one variable. First thing you do, make sure it's in order. Okay, biggest exponent on down. You can skip exponents, that's okay. It just has to be in order. So the first one we have 8x to the 5th minus 4x cubed plus 2x squared minus x minus 3. Is it in order?
Yes.
Yes. All right. Make sure there's only one variable in it. Is there? Whoops, wrong screen.
Yeah.
Is there one variable? Yeah, it's just x's. All right. So once you see that, you have two questions to answer. What's your degree? And what's your leading coefficient? Okay, the degree is the biggest exponent, so in this case that would be 5. And the leading coefficient is what's attached to it, so it would be 8. Okay,
Would that be 8x?
just 8, just the coefficient. Okay, does everybody see that difference? Just that you want just the number. All right, that's your answer. Yeah,
Oh, that's it?
that's it. You can. Okay. So number 2. So the second one, we have 12x squared minus 3xy plus 8x. What's the problem with that one?
It has two variables.
It's got two variables in it. Okay? It's got two variables in it. So it's not a polynomial in one variable, so you just write not one. Just write not one variable. All right? That's all you got to do.
Like no solution.
Kind of, but tell me why. Okay? It's kind of like no solution, but tell me why.
So for this one, we take not in order. You just told me.
Do you guys care about the characters or something?
Okay? Everybody good? All right, last one. Is it in order? No, so you got to make it so. Okay, double check. Obviously make sure it's not in one. It's in one variable right away. Okay, but go from highest to lowest. So -4 x to the 8th plus 3x to the 4th plus 6. Hang tight. 6x cubed plus 2x. All right. Then ask yourself the same two questions. Degree. Degree is going to be 8. Leading coefficient is going to be what? -4. Okay? Now, do you have to rewrite it? No, you don't. Okay? But here's your words of warning. All right? Nobody messes up the degree. Nobody. Haven't seen it yet. Everybody can point out the biggest exponent in a lineup. Okay? What people do mess up is the leading coefficient for two reasons. Number one, it is called leading coefficient because it's the leading term when it's written in standard form. This is not in standard form. All right? So sometimes what I'll see is degree of 8, leading coefficient 3. All right? You laugh. He who laughs is usually the one that does it. Okay? So, the other thing, what's the other wrong answer do you think I see a lot?
6.
Just 4. Okay, who said that? Easy. Fill in. Okay? Just 4. Alright? Whatever sign is ahead of the number goes with it as well. Okay? So, if you can handle those two things, no, I don't necessarily need to see you rewrite this. Alright? Jazz?
You said we won't have like exponents in the same number.
Yeah, you should. Yeah, for this type of problem, you won't have to like combine like terms or nothing.
No, I mean like if we had like in the third, and like the third one is like plus x, plus 6x to the 8th, and then like minus 4x to the 8th.
No, you won't have anything like that. Okay, shh, guys. Hey, I'm not gonna tell you again. I'm about ready to start kicking people out. All right, ease.
Second answer to this is 5.2. No, yeah, 5.2. And we had that set up. Instead of 0x to the 7th, 1 can we just put 0x to the 7th through 0x to the 5th?
Okay. Now, last thing I'm gonna say about this slide. Pay attention real quick. Okay, I'm gonna change one thing. What does that change about this last one? What's it do? Okay. Anybody know? Look at your definition. Exponents have to be what? Positive. If your exponents are not positive, then you have not a polynomial. Okay? So this is also not a polynomial because of negative exponents.
So you don't move to the bottom.
Correct. Okay?
And I have a question.
What's up? Okay. Everybody good here? The rest of the day, the rest of this lesson is going to be evaluating polynomials, all right? And this kind of goes to what we started the day with. All right? Now, the differences are a few things. Number one, they get a little harder. Okay? You guys are going to notice a lot of these are stuff you guys have done before. A lot of this semester is stuff you've done before. It's just getting harder. Okay? So, find 2f of 4 if f of x equals x squared plus 2x minus 3. Okay? My suggestion is this. Always start with what you know how to do, which obviously you all showed me earlier. You know how to do f of 4. So you plug 4 in where? Into the x's. Okay, so we have f of 4 equals 4 squared plus 2 times 4 minus 3. Answer.
I do the next step.
Sure.
Should we just and then put 2? What? 2.
Not yet. Hold up. Do this first, okay? Just shh. Do this, okay? 16 plus 8 minus 3. Okay? Hang tight. 16 plus 8 is 24. 24 minus 3? 21. Okay? Now, that's f of 4. How many of those do you need? 2 of them. Okay? Right here between the 2 and the f of 4, that's multiplication. So you have to multiply 21 by 2 to give you a final answer of 42. Okay? A little complicated. Okay? Just a little. Yeah, a little. All right? Actually, it's a lot complicated. Okay? I'll be real. This is hard. Okay? The key, and I'll tell you guys this, I'll see it every time. Make sure you know where to plug in what. Okay? And what I mean by that is this. People flip-flop where they plug in stuff. Okay? Where it says f of x, it'll always either say f of x or g of x or maybe h of x. Usually one of those three. That's the one you are plugging into. Okay? CUDA likes to show off h of x's, so you'll probably see it soon.
You said Alexa?
The CUDA software. H of x. Okay?
I thought that was Amazon. Whoa. What?
Why?
Oh, I didn't know I said that loud. I'm so sorry. Scared me.
Flipper.
This f of x
Function. Don't worry about it. Same process holds true. Okay, now, I do suggest you split this problem up. Okay? I do suggest you split this problem up into two spaces, or two parts, all right? The first part being f of 3c minus 4, the second part being 5 f of c. Okay? We'll get there. We'll get there, okay? All right, so f of 3c minus 4. Okay? Now, just like if it was a number, you would do what with that number? If it was a number, if that was just f of 2, you would... If this was f of 2, you would plug it in the x's. Doesn't change because it's 3c minus 4. You plug it in for the x's and you put it in what? When you plug it in, you put it in parentheses. Okay, so 3c minus 4 is being what? Squared. Plus 2 times 3c minus 4 minus 3. Okay?
Question.
Answer. I would write it just to keep your stuff organized. Okay, Dylan?
Where's the negative 5?
We're going to come back to it. Okay, we're going to split this up into two parts. All right? Okay, now, without giving away 3c minus 4 quantity squared.
What F do you have to write on there?
Oh, I said it.
Foil. Because you're doing 3c minus 4 times 3c minus 4.
So you would
Why could you do
Ah.
6c squared?
Because the exponent rule you're trying to apply goes for if it's all multiplication inside. Okay? Not when there's a subtraction. When a binomial is being squared, you foil it. Okay? So you have to foil 3c minus 4, 3c minus 4. All right? Everybody good with that?
Why? Why did you include it?
3c times 3c gives you what? 9c squared. 3c times negative 4? Well, 3c times negative 4. Negative 12c. Okay, now stay with me. Negative 12c. The next FOIL is going to be negative 4 times 3c, which gives you what? Negative 12c. So to save yourself a step, combine those right away to give you what? Negative 24c. Okay? Otherwise, you'll have to throw an extra step in there, and it's going to cause you more headaches. Okay? Negative 4 times negative 4? Plus 16. Okay? That is all that.
This is, what you call it, order. It's in order.
That's okay, because we're nowhere near done yet. Okay?
You just add on 2 times 3.
Now, the 2. What do you do with the 2 parentheses 3c minus 4? Distribute. Okay, so this becomes plus 6c minus 8 minus 3. Whoops, hold on.
Can we just save a step?
Minus 3. Okay, now you're going to combine all of those like terms. Okay? So 9c squared is alone, right? Minus 24c plus 6c gives you what? Negative 18c. Plus 16 minus 8 gives you? 8. 8 minus 3 gives you? 5. Okay, now remember what we did. Okay, we split this up into 2. So all of this equals this.
So you got to plug it back in.
Okay?
Wait, hold
Shh,
on.
shh, shh, shh. Jazz.
You say, but you got, how did you get 5?
16 minus 8 gives you 8,
Right?
and then 8 minus 3.
Oh, dang.
Okay?
So, oh, that's it.
That was f of 3c minus 4. Now we have to do f of 5, or 5f of c. Okay? So 5 f of c. Which means you replace what? You replace the x's with c, and then you're going to multiply it by 5. All right? So you can kind of do that in 2 steps, hopefully. So 5 parentheses c squared plus 2c minus 3. Replacing, you replace this one, remember?
No, like, okay, so can you redo that whole thing that you've done so
Okay. F of c, you replace this f of x with c, right? Okay, so then replace the x's with c, which gives you c squared plus 2c minus 3. Okay? You need 5 of those, right? All right. So we're going to distribute this 5 next. Okay? No, I haven't forgotten about the negative. Okay? So distribute 5. Or actually, you know what? Back up. Include the negative. It'll make it easier, now that I think about it.
Does that, can I just put that in between the signs?
So distribute negative 5. Okay? Now, negative 5c squared
Negative 10c.
minus 10c plus 15. Okay, Jasmine?
So, like, if I didn't do, like, negative 5, like,
You would have to distribute later.
but isn't that just your negative, I mean, like, your subtraction sign in between?
Right. That's exactly what I'm taking care of right then.
Oh, okay.
Okay.
But it doesn't-
You can do it one of 2 ways. Okay. You can either leave this as 5 f of c down here, distribute a positive 5 through, but when you go set it up again, you're going to have to distribute the negative when you subtract. Okay, because everybody see long term or next steps combine like terms. Okay, so you have 2 choices: either distribute a positive 5. Don't worry about the negative till the end, but truth be told, you're going to distribute it anyhow. Okay, so distribute the negative ahead of time, gives you this. Now take what f of 3c minus 4 was, which is 9c squared minus 18c plus 5. And now combine those 2's like terms. All right? So 9c squared minus 5c squared gives you 4c squared. Negative 18c minus 10c gives you negative 28c. 5 plus 15? 20. Okay, listen, this is important, okay? Here's where this gets tricky, all right? Your homework for this section is page 326, 1 through 10, okay? 1 through 4 is describing state degree leading coefficients, all right? 5 and 6 are just like what was up here on the board. 7 through 10 is like what we just got done doing, okay?
It's only 3 o'clock.
Okay? Now, 2 more things. Okay, 2 more things. Number 1. You have a video on Edpuzzle posted. Okay? You are hereby assigned to watch it by next Tuesday at 8:15 a.m. I don't know, halfway between first and second bell.
Is there any way to know if you don't watch it?
Yes. I will know. I'll tell you that right now. I'll know if you watch or not.
How long is the video?
15 minutes.
Would you know if you watched the full video?
Yes, I will know how much you watch the whole thing. Okay? Shh. Hey! Shh. Okay? I will know how much you watch. The reason you are watching this video is this. I'm not going to really go over what it's in class, what it's talking about. It's pretty much, hopefully, common sense once you watch it. It's not super important for what we have to do going forward. It is important, though, that I want you to know terminology. It's basically for your vocab quiz.
Oh, when is that?
Okay? Later. All right? That's first off. Okay? Second thing I still have to say. All right? We'll go over your quizzes like some other time. They ain't going to get done today. People that need to take them, make sure you get in to take them. Okay? I guess there's 3 now, because that was kind of its own thing. Third. 7 through 10 are a lot like this. Okay, like the one we just got done doing. Okay? However, there may be some difference. Okay? If you think about it, you'll be fine. Okay? The one that basically I'm talking about 9 and 10 for the most part. Alright? You should be good. Once again, you will get potentially bigger numbers. Okay? You'll be in the thousands one time. Okay, 1,500 one time. All right, so don't freak out just because you have big numbers. All right, try them. Next day I see you, whatever that may be, we will go over those 4. All right, this is complicated stuff, people. I'm telling you right now. This class gets harder. Okay, and what some people are doing right now while I'm still talking is very disrespectful, and I'm getting really sick and tired of it. Sick and tired of it. You want to do better in here? Then keep your mouth shut when I'm teaching. It's that simple. That'll help a lot. That'll help a ton. Okay? Because your quizzes, while good, I mean, 80's okay. 80's alright. Nothing wrong with that. C's average. There was a lot of mistakes that made me cringe. Okay? And stuff that I thought would be better. Okay? Combining like terms, especially. Okay? That's stuff you guys have known to do for years. And yet, here it was, alright? This class gets tough. Okay? I'm telling you that. I will not lie about that. This class, this semester gets tough. If you want to do well, you have to put in the work. End of story. I don't